Welcome to Chapter 6 of your Geology Interactive Notebook. On page 67, you're going to explain why when surface area increases, the rate of weathering in a rock will also speed up. So you're going to create a legend with just a few sentences to explain this figure and what it's showing. On page 68, there's a diagram showing frost wedging. And you are going to describe the process of frost wedging and how it occurs. So how does this break down rock at the surface of the earth? On page 69, you're going to explain the process of sheeting and how these sheeting fractures develop in a rock, and then also explain how it will weather rock. And then also tell me what rock would be more susceptible to this type of weathering. And again, this is a mechanical weathering process because it's just breaking down rock into smaller pieces at Earth's surface rather than chemical weathering. On page 70 of your notebook is the type of weathering that is caused from life, so biological weathering. And in this figure, on this page, I want you to explain how biological components at the surface of the earth can break down rock. Okay, so this is just one example, but I want you to draw out another example of a second biological weathering process, and you'll complete this on page 70 of your notebook. On page 71 is a diagram showing spheroidal weathering, and this is very common in granitic or volcanic rocks. And there's a great example of this in Arizona. So on this page, you're going to create a legend. My husband is dancing right now, trying to make me laugh on camera, so good job, he did it. On page 71, you're going to create a legend that thoroughly explains how spheroidal weathering occurs. Tell me what type of weathering this is. So is it chemical or mechanical? And what is the difference between the two? You want to put that explanation on this page. On page 72, shows you the different grain sizes and classifications for wind erosion. So these are the different sizes of grains or sediment, loose rock material that would be carried by wind. So on page 72, it gives you a great diagram to tell you the grain size breakdown and which components or which sizes of sediment would get carried with wind, and depending on the energy in the environment. And then on pages, so use this page to help you with pages 73 through 74. So on page 73 is showing you the types of erosion that occur with wind. So depending on the grain size, you'll see a different type of erosion. On page 74, you'll see the same types of erosions. We use the same terms, and there's just one more: solution, which is when minerals are dissolved in water. This is causing a chemical change, and it's the lowest grain size or the smallest grain size that would be a solution. And so you want to explain what this type of erosion is a function of. So I've pretty much given you the answer here, but you want to describe what the grain size or how the grain size relates to the type of erosion that will occur. And you need to know these terms. You should know suspension, solution, saltation, and creep. In this water erosion, they use the term traction, but I just use the same term for both wind and water. All right. Page 75 is the last page in chapter 6, and it is showing you the diagram of the rock cycle. And you're going to provide an example using the rock names and depositional environments as to the life or the cycle of sediment from sediment all the way through a lithification, turning into sedimentary rock, and then through metamorphism. So describe the environment and what would happen to this rock in this process, and describe each process in a way that a rock can be turned into any other kind of rock. So how could you start at a metamorphic rock and go into igneous rock, igneous to metamorphic, igneous to sedimentary, sedimentary to igneous. So just make sure you include all of those possibilities there. And it should cycle through because it is a rock cycle. All right, that concludes chapter 6.